What's going on, guys? I just had to film this effect, and again, here's the schematic. Feel free to pause it on the schematic for the transmitter. So I'm always going to show the schematic now, and it's in the YouTube posts section too. And feel free to play the video at 1.5 times speed. The system is constantly being upgraded and evolving. It's built upon the theories of Steinmetz, Eric Dollard, Ken Wheeler, and Nikola Tesla. And it's using an AETHER or ether physics-based framework to operate, and it seems to be very rewarding. So this was the upgrade made. This is a huge reactive resonator coil, and read the pinned comment on the channel. The pinned comment has full detail on everything, how to build it. Read the pinned comment, because the description is getting too long to put in the YouTube description. So this huge reactive resonator rebounds the power, focuses it back into itself. It's almost looking like an onion type of design. Everything is following the golden ratio with it. Added a small capacitor value on the DC output of our upgraded diodes. They're more efficient than the SR560. They just came in. They are these guys right here. These are the upgraded diodes. So they're the STP S5L60. Very efficient. So anyway, for those who don't know, we have a very efficient transmitter. A two-part receiver coil sits over it. The inner part of the receiver coil is 24 gauge Litz wire, builds up immense reactive power. The outer power takeoff coil turns that reactive power into real power by following the Steinmetz method and converting reactive power into real power by performing the J operator. So we're able to synthesize excess power from the reactive domain. Now, the system is untuned, inefficient. We're consuming almost 1 amp. Watch when I put the reactive resonator over the system and I get it tuned. Now watch when I get it tuned. I will slowly start to get it tuned. Watch what will happen. See if we can get our brightness on the meter displayed nice here. And we'll do one more, is what it likes. So this is where it gets crazy. Get everything perfectly centered. That's how the whole arrangement looks. It also works really good for some reason when they're slightly staggered to each other. So when it looks something like this, like boom, 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 that is our power consumption. I've seen it even go lower than that to 0.22. See if we can get it better. But here, this is the negative resistance effect I wanted to show. So look at this. When I disconnect the load, we consume more power. When I connect the load, we consume less power. So I'll show that effect multiple times. Very interesting effect. Here's how it looks. And I can really tune it with the ferrites by removing a ferrite or two, or the whole bundle can be moved. Now watch what happens when I backfeed the power back into the system's driving battery. I want you to see the sparks upon contact and what our voltage does. So we will immediately climb in voltage, and it will regulate itself. Our new equilibrium point is now very high due to all the tuning of the system of what we achieved. So we will now climb in voltage despite consuming more current. That effect is easily demonstrated multiple times. I'll disconnect the feedback. Consume less current and we drop. Connect the feedback again. Something's out of whack here. I'm not sure why the system shut off. happened? It was working good. Wonder what happened. There we go. We're back on. Okay, had a bit of a hiccup. Everything is so fine-tuned now. Oh, I think I disconnected the wrong one, so it's the middle. There we go. That's the effect I wanted to show. So when I remove feedback, the transmitter consumes less current and we drop in voltage. Connect the feedback, we go up in power, despite the transmitter consuming more current. That's what I wanted to show. And again, this is the coolest effect. This can be powered for completely free while it's in feedback mode, and you get this tuned with the right ferrite. I might need a thicker ferrite to do this. Here it is. Watch that light. Not sure if you can see that, but that's lit completely for free, just being near the transmitter. And if I put the correct capacitor value here, it'll get very bright. See if I can demonstrate that effect. If I put the correct capacitor value in parallel with this coil, the light will get very bright for free. I'm going to show that. Oh, our connection came off. Duh. And we dropped stuff. Filming one-handed. About to go to work. Just have to show these effects. Gonna have to bear with it for a moment. Get this thing tuned up again. This additional receiver. It'll eventually stay. Okay, so we got it lit for free. That is being lit for free from the excess field energy. Now here's what happens when I add the capacitor. It will get very bright, as you see. So that little LED is getting much brighter just from the tuning capacitor. So that's that, and I'll show you what happens when I put this coil over the ferrites. Look at that. Very bright, just sitting over the ferrites. So, figured I would demonstrate that. We actually hit 3.8 for a moment on the transmitters. Regenerative recharge. There we go, we hit 3.8. So, the new equilibrium point is 0.40. With the thing, and again, it's just so cool and so simple. This coil reflects all the energy back into itself. I just can't get over how cool that is, and we see that effect working in real time. Put it back over, and we immediately go to 3.8. And this coil is just a resonant reflector coil, being at 3.8 inches, which is another golden ratio harmonic of the 2.4 two-part receiver coil that does real work. And the transmitter is a two-part 1.48 inch long 24 gauge wire, solid core magnet wire, dual core resonator. So wanted to show that. The supercapacitor in parallel with the battery overcomes recharge bottlenecks if you deeply discharge the system. So the supercapacitor bank acts like a power reservoir for energy. Can just run loads. It'll recharge itself back up. I'll show it running a load for a short time. Just wanted to get this effect filmed and shown how the system is constantly upgrading and evolving. I don't want anything to short out. See if we can do this without shorting out. Okay, here we go. So we will go for 2 minutes and then I'll disconnect and we'll watch what happens. I also had to get rid of the LED because it burned out and shorted the system out, but I found out that adding this reactive resonator coil over the system enhances it much greater too. So we'll go for 2.5 minutes or 2 minutes. And of course, when the system is on, a near magic-like field exists around the whole area that those lights are drowning out. So, just this reactive resonator coil is boosting the whole wireless power field without having to do anything, which is very cool. And I bet if I lift this up, our battery voltage will drop even quicker. Okay, now I'll add the coil. That is interesting. The system's actually consuming more power with the reactive resonator over it while it's running the bulb load, but I did notice it enhances the recharge. Ooh, nope, there's that effect we're looking for. So it does go into very efficient modes at times. It'll cycle between a super efficient mode and consuming like 0.21. And, oh, there it goes again. You see it? It's going up. I'm not exactly sure what causes that. Maybe it's the position. Anyway, we'll go to 12 minutes and 30 seconds and I'll disconnect. There it goes again. You see that effect? It's dropping in current consumption. Now it's going up. I'm not sure why it's doing that. Well, that's a 72 watt load. The system will regenerate and recharge itself from all the upgrades made. And then I'll try and explain everything as best I can, and the full detailed description will be in the top pinned comment on the video. So now I will disconnect the light bulb load, and we will watch what happens. This area will be very hot. Should recharge even quicker in theory from all the upgrades we made. We upgraded our diodes to be 30% more efficient, our rectifiers. We added the additional huge golden ratio resonator coil that reflects any wasted power back into the receiver coil that outputs power. So should even be better in theory. And we're going to watch that recharge. And again, there's just a crazy field around the whole area, even more so from that resonator coil. And I just can't get over how cool that is. You can set up a distant coil nearby with an LED and get it tuned and it will light. And if you have the correct capacitor in parallel with it, it'll light very bright. So that is just really cool in my opinion. So I'll try and add the correct capacitor. See if we can add the correct parallel capacitor and show you that effect. Oh wow, that got very bright. See that? Just from the correct parallel capacitor. So we're tapping the excess field energy that is multiplicative, not additive, with the system. And feel free to get our free book on archive.org, link in the description and the top community post. And this is about to fall. Yep. So, just wanted to show that cool effect. And we can be here all day charging and discharging the system. It always goes back up. So I wanted to demonstrate that effect. Once it hits 0.38, I'll disconnect the system, show all parts and pieces of it again. And every single component value is listed in complete detail now in the top pinned comment of the video, because the description is getting too long to fit in the YouTube description. So that's where it will be. The system is behaving with magic-like properties due to the way it's built. So we will go up, and I'll try and demonstrate that effect again. Make sure my meters don't shut off. So the moment it says 3.7 on the recharge, I will disconnect the feedback and show you what happens. Try and get that all in frame. Make sure my hand's not in the way too bad. So I'm going to disconnect the resonant feedback the moment it says 3.7. And what we will see is the transmitter will consume less current and our voltage will drop, which is the sign of the negative resistance effect. So the moment we hit 3.7 on the battery recharge, our transmitter current will drop a little bit, and our battery voltage will drop as well, which is interesting. It's like we're consuming more current, but it doesn't matter. We still hit a higher recharge. Okay, I'm going to do that now. See that? See that? I remove the feedback. We immediately drop in charge. I add the feedback. We immediately go up in charge on the battery. I'll do it again. So I'm showing these effects in real time. There can be no argument. Add it again. So by removing the feedback, you see that? And the transmitter is in some kind of weird, like, self-regulation phase or something. And it should say 3.8 again. So say 3.8 any moment. System has never failed me yet. It's all a matter of very fine-tuning. I wonder why it's taken a while to say 3.8. It should eventually say it though, nonetheless. Maybe I have to move a couple things, get it more tuned, and it will eventually say it. And we just keep pushing the net gain equilibrium point to the battery higher and higher with each improvement. See if we can get this just right. Might have to tweak the outer capacitor value here just a little bit, because I tweaked this value for optimal performance when powering an incandescent bulb from the inner receiver coil. So when you power a bulb, it's different than when you're backfeeding the battery. Let's see if we can get this to say 3.8. There we go. We said 3.8. So just a matter of wiggling some things around and getting it tuned. I will remove feedback removed, drop to 3.7, add the feedback. We go to 3.8, show that effect again, feedback removed, we drop, add the feedback again, we go back up. So we can be here all day doing that. Now I will disconnect the system, show you all pieces of it. Transmitter's off. It's the heavy ground connection down here. Goes to my heater. Here's the reactive resonator coil at a golden ratio proportion, being 3.8 inches long. The receiver coil here. It's almost like the system doesn't use power now despite performing operations. The tuning rods. The upgraded 2-part receiver coil that converts reactive power to real power. Our upgraded diodes, I already showed you those earlier in the video. Good look at the receiver coil so you can rebuild it yourself. Made with 18 gauge stranded wire for the outer coil, 24 gauge Litz wire for the inner coil. Nice clear look at it with our upgraded diodes. These are the upgraded diodes we are using for the full bridge rectifier. Very efficient. STPS 5L60. 30% better than the SR 560 that we upgraded from. Good look at the transmitter. The inner red L1 trigger coil is wound first to the left. The outer L2 power coil is wound to the well, no, hold on. The inner L1 red trigger coil is wound to the right. The outer power takeoff coil is wound to the left. You can see it right there. Full description in the pinned comment on the video. This essential 9 nanofarad ceramic capacitor has to be installed on the DC power input line, very close to the transmitter. Can't be installed further away or closer than that. That exact spot enhances the transmitter's efficiency with its switching. It makes the switching more efficient. The 2.2 nanofarad capacitor in parallel between the L1 trigger coil and the emitter enhances efficiency as well. You have to use a carbon film 1 watt biasing resistor between the collector and the L1 coil again. L1 coil on the bottom also gets earth grounded. The base of the coil goes to, or I'm sorry, the inner coil, inner red coil, connects to the base of our transistor. A flyback Baker clamp diode connects cathode to collector, anode to base in the system, speeds up switching further, and a 2.2 nanofarad parallel capacitor between the base and emitter of the vital ST1309 transistor is used. You have to use an ST1309 transistor. It just works like magic with the system. Don't know why. Has to be from Newark, NEWARK. So that is the system. I think I explained everything, showed you everything elegantly. That's the supercapacitor that's soldered in parallel with the battery. I'll remove a couple connections, show you everything again. So this is how it looks. Very dead simple. Didn't even use this coil yet, which is an additional pickup coil wrapped over the battery. Try and move this. So I showed you everything. Here's the look at the receiver coil again, and we saw what the system did. Look under the wood board, so there can be no complaints about anything. And a look under the desk. So feel free to like, comment, subscribe, join the Patreon, follow the works of Eric Dollard, Ken Whaler, the ESTC group, myself. Get our free book on archive.org, link in the description. And thank you, everybody.